All right, so we know that vectors have magnitude and direction. Remember that magnitude means it has a number, like a scale, like 4, 48, 52, and direction north, east, right, west. We've seen this as far as displacement, velocity, and acceleration. All those are examples of vectors that you're familiar with. So really they're represented with like an arrow, but you have to have that line too. And that arrow shows direction. All right, we reviewed this yesterday, but just in case, when you have them in the same direction, you add the values. When they're in opposite directions, you subtract them. When you have them in two different directions, like that, you're going to use that Pythagorean theorem. So for example, Sally can swim at 2 meters per second in a river that flows east at 1 meters per second. How fast can she swim with the current? So in the same direction of the current. Since she's going with the current, that means they're going in the same direction of the current. So you would add them. So 2 plus 1 is 3 meters per second east in that particular river. So then how fast can she swim against the current? Because those vectors are in opposite directions, we subtract them. She's got to be swimming west. Now, this isn't technically the way you would want to draw this. You'd really want it more like that. That actually would show the direction. But to be honest, this is what most people would draw just because we think of Sally being the main point of reference. If you draw it like this, you're going to have to keep in your head which direction she's going, what direction's the opposite, and whatnot. So ideally, this would be what you wanted to see, not that. All right, so then if they're in two different directions, north and east, south and west. So that. So you'd want to make a triangle. Then you'd want to find the angle. To find the angle, we would use theta equals the inverse tangent of y over x. Just write it and then we'll talk about it. This is shorthand for angle, just tower right angle. Lucy gets to go on a hike. She's very excited about going on a hike. She walks 3 meters north, 6 meters west, then 7 meters north. What is her displacement? In the northward direction, she's walking 3 meters and 7 meters. Because they're both going north, I can add them. So totally, she's walking 10 meters north. So remember, with displacement, what really matters is stop to start. So we'd want to find that hypotenuse. Another word for this would be the resultant. So Pythagorean theorem, a squared plus b squared equals c squared. 10 squared plus 6 squared equals c squared. 10 squared is 100. 6 squared is 36. You add them together, you get 136 would be c squared. So the square root of 136 is going to be 11.66 meters. Now, in the past, we've just said that's good enough. She's walking 11.66 meters northwest. That's no longer good enough. Because when you say something like northwest, people just assume it's a 45-degree angle. You're walking exactly the same amount north as you are west. That is not the case. So we need to find that angle, which we use theta. It's hard to see here. It looks like that. So that formula is the inverse tangent of y over x. Now, before you get excited, I need you to take out your calculators, please. I don't know everyone's math class, so you might want to check with your math teacher, make sure it's okay to stay in this mode, but you have to be in a certain mode to calculate this out. So sorry that my calculator really needs a bath. All right, we're going to turn it on. Let's zoom out a little bit so you can see my everything. All right, my calculator is on. I'm going to hit second, my blue button. That gives me error right here. I'm going to hit mode. And that's quit, right? Because I don't know what screen you're on. Now, you should be at a blank screen or one with just like numbers on it. I want you to hit mode one more time. I want you to go down 1, 2, 3, and I want you to make degree flash. You make it flash by making sure it's highlighted and you hit enter. Your degree should now be flashing. Now I want you to do that second mode again to quit. Your calculator has to be in degree mode. All right, to solve for this angle, we get the inverse tangent of 10 over 6. So you should see the tan button. Above it, you'll see little blue letters that say tangent to -1. That's an inverse tangent. So to get that, I have to hit blue, tan, and it shows me tan to -1. 10 divided by 6. Close the parentheses, hit enter. And it should get you 59.03 degrees. If it did not get you 59.03 degrees, you probably didn't put your calculator in that degree mode. Not in the degree mode, I think gets you like 1 or 11 or something. So we want to make sure you're in that degree mode.
Yeah,
check.
1.0.
Yeah, 1.0. So check with your math teacher, make sure it's okay that you're in the degree mode. Otherwise, you're going to have to change back and forth. There's nothing I can do about that.
So wait, what was the point of getting 11.66?
This is part of our answer. So Lucy's displacement is 11.66 meters northwest at an angle of 59.03 degrees. . that would be her displacement.
Can you do some math, please?
Okay, I need you to look at the paper that you should have picked up on your way in. You're going to see these formulas on there. We just covered this one, so you should be good on this one. This one may look a little funny. Remember how we call this a hypotenuse? In physics, we also call it the resultant, which is R. This is the Pythagorean theorem. If you did a squared plus b squared equals c squared, and you set it solved to c, it would be the square root of a squared plus b squared equals c. Now you can see x should be here, y would be here. So this is the same formula you're used to seeing. It's just solved for that resultant. You can use this one if you want. You can use the Pythagorean theorem. It's the one I just typically go to. Why? Because we've had that theorem drilled into all of our heads. It does not go away. But you can do you. So is it okay if we practice one before I let you go? Is that cool? Okay, I like pirates. So you're going to turn it over to number 7. Pirate follows directions on his treasure map: 14 paces north, 70 paces west, 30 paces south, 20 paces east, 83 paces north, and 41 paces east, 27 paces north, and 53 paces west. Where is his treasure located compared to where he started? So the way I would solve this is start by figuring out the direction. So I'm going to do north and south, then east and west. So north, we had 14 paces. $83 paces. And 27 paces. South, 30 paces. East, we have 20 plus 41. And west, we had 70 plus 53. Okay, I'm crossing them out as I go through it so that I know I've used them. All right, what do you do with vectors in the same direction? You add them. So 14 plus 83 plus 27 should give you 124. 20 plus 41 should give you 61. And 70 plus 53 should give you 123. Now, north and south are opposite vectors. What do I do with opposite vectors? Subtract them. So 124 minus 30 gives me 94 in the north direction because my north is a bigger number. 123 minus 61, 62 west. So his displacement is that resultant vector or the hypotenuse. So again, if you want to use the one in the front of the formula with r equals the square root of x squared plus y squared, feel free. It's the same formula, I promise. 1,126. Woo, let me say that number again. 112.6 paces northwest at what degree? So now we have to find our angle.
So we're finding like the a squared plus b squared plus c squared, and then we're putting it into the tan?
Yep. Okay, to find that angle, the inverse tangent of y over x. So y is 94 over 62. Should look like that. $56.6 degrees. So what y'all got? Cool. So the pirate's displacement is 112.6 paces, because it's pirate, he doesn't use meter sticks, he uses paces, northwest, at an angle of 56.6 degrees. Or you can say 112.6 paces at 56.6 degrees northwest. Either one of those is fine. On this worksheet, please make sure you circle, highlight, or square that so I can find it. And you should be good to go. What questions do you have?